Caesar was killed by his senators in March of 44 BC. His last phrase most likely was, "You too, child," which referred to Marcus Brutus, who took the leading role in the whole assassination. So that was the moment of Caesar's last breath. What if I ask you to estimate the number of molecules in your lungs that Caesar exhaled in his last moments? No matter how crazy this question sounds, we can actually answer it using some simple physics. The only two things that we need to know are the total number of molecules of air in our atmosphere and the amount of air exhaled by Caesar. Let's start with the atmosphere. Our planet is approximately a sphere of radius 6,500 kilometers. To estimate the volume of the atmosphere, we need to multiply the surface area of Earth by the height of the atmosphere. The only problem that we have is that the density of air changes with height. We need to simplify it, and this is how. We know that air pressure is approximately 100,000 pascals. Pressure is force over area, and force is mass times g, and mass is density times volume. So what if we assume that the density of air is constant? What is going to be the height of the new fictitious atmosphere? Well, from this equation we see that for area equal to 1 meter squared, we get that 100,000 is equal to rho times V times G. But the volume is equal to height, because the cross-sectional area is 1. The average density of air near the surface is equal to 1.25, so we get H is 100,000 over 1.25 times 9.8. So H is approximately 8,200 meters. Right, we are now ready to complete the first part of our problem. Surface area of a sphere is 4 pi r squared, and r is equal to 65 times 10 to the 5 meters. Substitute our result for height. Overall, we get 4.4 times 10 to the 18. The second part is easier. An average human fits 6 liters of air inside his lungs, so we can assume that Caesar exhaled 1 liter of air. But what is the number of molecules? We of course need to use Avogadro's number. 1 liter of air contains approximately 2.7 times 10 to the 22 molecules. Finally, we just need to divide this number by the number we got in the first part. We get 600. 600 molecules that Caesar once exhaled and can now be inside you. Under many assumptions, of course.